Question 1. The efficiency study reveals that a critical e-commerce application, served by a BIGIP LTM, is experiencing intermittent periods of slow response times and occasional connection timeouts, impacting customer transactions. The LTM is configured with a virtual server directing traffic to a pool of web servers. The issue is not consistently reproducible and appears to occur randomly. Which of the following troubleshooting approaches best aligns with maintaining service integrity and adhering to operational best practices for the BIGIP LTM? Option A. Immediately initiate a full system rollback of the BIGIP LTM configuration to the last known stable version without further investigation. Option B. Escalate the issue directly to the application development team, assuming the problem lies solely within the application code, without validating LTM performance. Option C. Focus exclusively on analyzing the network infrastructure upstream and downstream of the BIGIP LTM, assuming the LTM is functioning correctly. Option D. Begin by thoroughly examining the BIGIP LTM's virtual server status, pool member health, monitor configurations, and relevant LTM logs for any anomalies or errors. Correct answer is A. Immediately initiate a full system rollback of the BIGIP LTM configuration to the last known stable version without further investigation. Explanation. Scenario analysis. This scenario presents a common challenge in network operations where a critical service is experiencing intermittent performance degradation. The challenge lies in accurately identifying the root cause of the issue, which could stem from various layers of the network infrastructure, including the BIGIP LTM itself, upstream or downstream devices, or even application-level issues. The pressure to restore service quickly, coupled with the potential impact on business operations, necessitates a systematic and informed troubleshooting approach. Misdiagnosis can lead to wasted resources, prolonged downtime, and potential financial or reputational damage. Correct approach analysis. The correct approach involves a methodical investigation that prioritizes the BIGIP LTM's configuration and operational status as a primary suspect, given its role in traffic management. This includes verifying the health of the virtual server, pool members, and associated monitors. The approach also correctly considers the possibility of external factors by examining traffic patterns and logs for anomalies that might indicate issues beyond the LTM. This comprehensive review, starting with the most probable cause and expanding outwards, aligns with best practices for network troubleshooting and incident response, ensuring that all relevant components are considered without premature assumptions. This methodical approach is crucial for maintaining service availability and adhering to service level agreements, SLAs, which are often implicitly or explicitly governed by regulatory expectations around service continuity and data integrity. Incorrect approaches analysis. One incorrect approach focuses solely on external network devices without first thoroughly examining the BIGIP LTM's configuration and health. This is a regulatory failure because it neglects the direct responsibility of the LTM in traffic flow and can lead to prolonged outages if the LTM is indeed the source of the problem. It also represents a failure in due diligence, as the LTM is a critical component that must be evaluated. Another incorrect approach involves immediately reverting the BIGIP LTM configuration to a previous known good state without proper analysis. This is a significant risk and a potential regulatory failure. While rollback can be a valid recovery strategy, doing so without understanding the cause of the current issue can mask underlying problems, leading to their recurrence or the introduction of new, unforeseen issues. It bypasses the critical troubleshooting and diagnostic steps required to ensure a robust and stable environment, potentially violating compliance requirements related to change management and incident resolution. A third incorrect approach is to assume the issue is application-specific and escalate to the application team, without verifying the BIGIP LTM's health and traffic flow. This is a failure in the principle of layered troubleshooting. The LTM is a critical network service that directly impacts application accessibility and performance. Neglecting to rule out LTM-related issues first can lead to unnecessary delays and misallocation of resources, potentially impacting the ability to meet regulatory obligations related to service uptime and performance. Professional reasoning. Professionals should adopt a structured troubleshooting methodology. This typically involves 1. Define the problem. Clearly understand the symptoms and impact. 2. Gather information. Collect logs, metrics, and configuration details from relevant systems, starting with the most likely culprits. 3. Formulate hypotheses. Develop potential causes based on the gathered information. 4. Test hypotheses. Systematically test each hypothesis, prioritizing those with the highest probability. 5. Implement solutions. Apply fixes based on confirmed hypotheses. 6. Verify the solution. Ensure the problem is resolved and monitor for recurrence. 7. Document the incident. Record the problem, cause, resolution, and lessons learned for future reference and compliance. This systematic process ensures that troubleshooting efforts are efficient, effective, and aligned with best practices for maintaining network stability and meeting regulatory expectations. Question 2. The evaluation methodology shows that an intermittent application performance issue is reported by users. The BIGIP LTM is suspected as a potential contributor. Which troubleshooting approach best aligns with maintaining service availability and operational integrity? Option A. Systematically verify the health of the BIGIP device. Review virtual server configurations. Examine pool member status and health monitor results. And analyze relevant LTM logs for anomalies. Option B. Immediately adjust the connection limits on the affected virtual server based on the assumption that the BIGIP is being overwhelmed. Option C. Roll back the most recent application deployment, as it is the most likely cause of performance degradation. Option D. Instruct users to restart their applications and devices, as this often resolves transient network issues. The correct answer is B. Immediately adjust the connection limits on the affected virtual server based on the assumption that the BIGIP is being overwhelmed. Explanation. This scenario presents a common challenge in network operations. A critical application is experiencing intermittent performance degradation, impacting user experience and potentially business operations. The challenge lies in accurately diagnosing the root cause within a complex LTM environment, where multiple factors can contribute to such issues. The pressure to restore service quickly, coupled with the need to avoid introducing further instability, requires a systematic and evidence-based approach. The correct approach, which involves systematically isolating and testing components of the LTM configuration and the underlying network, represents best professional practice because it aligns with established ITIL, Information Technology Infrastructure Library, principles for incident management and problem resolution. This methodology emphasizes a structured troubleshooting process, starting with broad checks and progressively narrowing down the possibilities based on observed symptoms and collected data. By verifying the health of the BIGIP device itself, then examining virtual servers, pools, nodes, and health monitors, a network engineer can efficiently pinpoint the source of the problem without unnecessary disruption. This methodical approach minimizes the risk of misdiagnosis and ensures that corrective actions are targeted and effective, thereby restoring service reliably and preventing recurrence. An incorrect approach that immediately jumps to making configuration changes without proper diagnosis is professionally unacceptable. This could lead to unintended consequences, such as further service disruption or the masking of the true root cause. From a regulatory and ethical standpoint, this demonstrates a failure to exercise due diligence and professional care. It could violate service-level agreements, SLAs, if the changes are not effective or if they worsen the situation. Furthermore, it shows a disregard for established operational best practices, which are often implicitly or explicitly part of professional conduct expectations. Another incorrect approach, such as relying solely on anecdotal user reports without verifying system logs and metrics, is also professionally unsound. While user feedback is valuable, it is often subjective and may not accurately reflect the technical underpinnings of the issue. Without objective data from the LTM and network infrastructure, troubleshooting becomes guesswork, increasing the likelihood of misdiagnosis and prolonging the outage. This can lead to a breach of professional responsibility to provide accurate and timely support. The professional reasoning process for similar situations should involve a structured decision-making framework. This framework typically includes 1. Incident identification and logging. Clearly define the problem and its impact. 2. Information gathering. Collect all relevant data, including user reports, system logs, performance metrics, and configuration details. 3. Hypothesis generation. Formulate potential causes based on the gathered information. 4. Testing and verification. Systematically test each hypothesis, starting with the most probable, and isolate variables. 5. Resolution and implementation. Apply the identified solution and monitor its effectiveness. 6. Documentation and review. Record the incident, resolution, and lessons learned to prevent future occurrences. This systematic approach ensures that decisions are data-driven and that troubleshooting efforts are efficient and effective. Question 3. Risk assessment procedures indicate that a critical customer-facing application is experiencing intermittent performance degradation and occasional unresponsiveness. As the BIGIP LTM specialist, what is the most prudent initial step to diagnose the issue? Option A. Focus solely on analyzing external synthetic transaction monitoring data without reviewing BIGIP LTM logs. Option B. Randomly adjust SNAT pool configurations to see if it resolves the performance issues. Option C. Examine the BIGIP LTM configuration for the affected virtual server, including its associated pool members, health monitors, and persistence profiles. Option D. Immediately begin troubleshooting client-side network connectivity and browser performance for affected users. The correct answer is C. Examine the BIGIP LTM configuration for the affected virtual server, including its associated pool members, health monitors, and persistence profiles. Explanation. Scenario analysis. This scenario presents a common challenge in network operations where a critical application's performance is degrading, impacting user experience and potentially business operations. The challenge lies in accurately diagnosing the root cause within a complex LTM environment, which involves multiple interconnected components. The pressure to restore service quickly, coupled with the potential for misdiagnosis leading to further disruption or wasted resources, necessitates a systematic and evidence-based troubleshooting approach. The LTM specialist must balance immediate action with thorough investigation to avoid introducing new problems or overlooking subtle but critical issues. Correct approach analysis. The correct approach involves a methodical, layered investigation starting with the most probable and impactful areas. This aligns with best practices for troubleshooting complex systems. By first examining the LTM configuration for the affected virtual server, including its associated pool members, health monitors, and persistence profiles, the specialist can quickly identify common misconfigurations or failures. The health of pool members is paramount. If members are marked down, the LTM cannot direct traffic to them, directly impacting application availability. Health monitors are the LTM's mechanism for determining pool member health, so their configuration and status are critical. Persistence profiles, while less likely to cause outright unavailability, can lead to incorrect traffic distribution or session issues if misconfigured. This layered approach prioritizes the most direct causes of service degradation and ensures that fundamental LTM functions are operating as expected before delving into more complex or less probable causes. This systematic method minimizes the risk of introducing errors and maximizes the efficiency of the troubleshooting process, adhering to the principle of least disruption. Incorrect approach is analysis. One incorrect approach would be to immediately focus on client-side issues without first verifying the LTM's ability to direct traffic. This is a regulatory failure because it deviates from a responsible and efficient use of resources, potentially leading to prolonged downtime and impacting service-level agreements, SLAs, which are often implicitly or explicitly governed by regulatory expectations around service availability. It also demonstrates a lack of due diligence in investigating the core infrastructure responsible for traffic management. Another incorrect approach would be to arbitrarily change LTM configuration parameters, such as SSL profiles or SNAT pools, without a clear hypothesis or supporting evidence. This is ethically problematic as it introduces unnecessary risk and potential for further disruption. From a regulatory standpoint, unauthorized or uninformed changes to critical infrastructure can violate compliance mandates related to change management and system integrity. It demonstrates a lack of professional judgment and a failure to follow established operational procedures. A third incorrect approach would be to solely rely on external monitoring tools without correlating their findings with the LTM's internal state. While external tools provide valuable insights, they may not capture the nuances of LTM behavior or internal errors. Ignoring the LTM's own logs and status can lead to misdiagnosis and a failure to address the root cause within the LTM itself, which is a failure to meet professional standards of thoroughness and can have regulatory implications if it leads to prolonged service outages. Professional reasoning. Professionals should employ a structured troubleshooting methodology. This typically involves 1. Defining the problem clearly. 2. Gathering information from all relevant sources, LTM logs, configuration, monitoring tools, user reports. 3. Formulating hypotheses about the root cause. 4. Testing hypotheses systematically, starting with the most probable and least disruptive. 5. Implementing a solution and verifying its effectiveness. 6. Documenting the process and resolution. In LTM troubleshooting, this means starting with the virtual server and its associated components, then moving to pool members, health monitors, and then more advanced configurations if necessary. This systematic approach ensures that the most likely causes are addressed first, minimizing downtime and preventing the introduction of new issues. Question 4. Compliance review shows that the BIGIP Local Traffic Manager, LTM, is currently configured to handle sensitive financial transaction data. However, the configuration allows for a wide range of SSL/TLS protocols, including older and potentially vulnerable versions, to be negotiated for these transactions. What is the most appropriate action to ensure compliance with data protection regulations and maintain a secure posture? Option A. Configure the BIGIP LTM to use SSLv3 or TLS1. 0 for sensitive financial transaction data, as these are widely compatible. Option B. Disable SSL/TLS encryption entirely for sensitive financial transaction data to improve performance. Option C. Allow a mix of TLS versions, including older, insecure ones, to ensure maximum client compatibility for sensitive financial transaction data. Option D. Configure the BIGIP LTM to enforce the use of TLS1, 2, or a higher version with strong cipher suites for all sensitive financial transaction traffic. Correct answer is D. Configure the BIGIP LTM to enforce the use of TLS1, 2, or a higher version with strong cipher suites for all sensitive financial transaction traffic. Explanation. Scenario analysis. This scenario presents a common challenge in network security and compliance, ensuring that sensitive data transmission adheres to established security policies and regulatory requirements. The professional challenge lies in balancing the need for efficient data transfer with the imperative to protect data from unauthorized access or interception, especially when dealing with financial transactions. The complexity arises from the potential for misconfiguration, the subtle differences between security protocols, and the downstream impact of non-compliance on audit readiness and potential penalties. Careful judgment is required to select the most appropriate and secure protocol that meets both functional and regulatory demands. Correct approach analysis. The correct approach involves configuring the BIGIP LTM to utilize TLS1, 2, or a higher version with strong cipher suites for all sensitive data traffic. This represents best professional practice because TLS1, 2 and above are industry-standard protocols designed to provide robust encryption and authentication for data in transit. Regulatory frameworks, such as those governing financial services, e.g., PCI DSS in the U.S., though this exam is U.S.-centric and we must adhere to that, mandate the use of secure protocols to protect cardholder data. By enforcing TLS1, 2+, the organization ensures that data is encrypted using modern, secure algorithms, preventing eavesdropping and man-in-the-middle attacks. This proactive measure aligns with the principle of least privilege and defense in depth, safeguarding sensitive information and demonstrating due diligence in protecting customer data, which is a core ethical and regulatory obligation. Incorrect approach is analysis. Disabling SSL/TLS encryption entirely for sensitive financial data traffic is a severe regulatory and ethical failure. This exposes financial transaction data to interception and unauthorized access, directly violating data protection regulations and security best practices. It demonstrates a gross disregard for customer privacy and data security, leading to potential data breaches, significant financial penalties, reputational damage, and loss of customer trust. Configuring the BIGIP LTM to use SSLv3 or TLS1, 0 for sensitive financial data traffic is also a significant regulatory and ethical failure. These older protocols have known vulnerabilities and have been deprecated by security standards bodies due to weaknesses that can be exploited by attackers. Continuing to use them for sensitive data transmission is a direct contravention of modern security mandates and exposes the organization to significant risks, including data compromise and non-compliance with data protection laws. This indicates a failure to keep security configurations up to date with industry best practices and regulatory expectations. Allowing a mix of TLS versions, including older, insecure ones, alongside newer, secure versions for sensitive traffic, creates a security loophole. While some traffic might be protected, the presence of weaker protocols allows attackers to downgrade connections to these vulnerable versions, thereby compromising the overall security posture. This approach fails to provide consistent and robust protection for all sensitive data, leading to potential breaches and noncompliance with regulations that require a uniform high standard of security for sensitive data. Professional reasoning. Professionals should approach such scenarios by first understanding the specific regulatory requirements applicable to the data being handled, e.g., financial data, health data. This involves consulting relevant compliance documentation and security standards. Next, they must assess the capabilities of the network infrastructure, in this case, the Big IP LTM, to implement the required security controls. The decision-making process should prioritize security and compliance, selecting the strongest available and compliant protocols and cipher suites. Regular review and updating of security configurations are crucial to adapt to evolving threats and regulatory landscapes. In situations involving sensitive data, a risk-based approach is essential, where the potential impact of a security failure dictates the rigor of the implemented controls. Question 5. Assessment of the most effective diagnostic strategy for an LTM specialist when users report intermittent application slowness and occasional connection timeouts, with no immediate indication of hardware failure on the BIG/IP LTM appliance. Option A. Focus solely on gathering more detailed qualitative feedback from affected users to understand the exact nature of their experience. Option B. Proactively adjust virtual server and pool member configurations based on common performance tuning best practices without initial diagnostic data. Option C. Systematically review BIG/IP LTM connection logs, event logs, and traffic statistics for anomalies, and utilize packet capture and connection table analysis to investigate specific traffic flows exhibiting issues. Option D. Immediately restart the BIG/IP LTM services and reboot the appliance to clear any potential transient states. The correct answer is C. Systematically review BIG/IP LTM connection logs, event logs, and traffic statistics for anomalies, and utilize packet capture and connection table analysis to investigate specific traffic flows exhibiting issues. Explanation. Scenario analysis. This scenario presents a common challenge in network operations, diagnosing intermittent performance issues that impact user experience and potentially business-critical applications. The difficulty lies in the transient nature of the problem, making it hard to pinpoint the root cause. The pressure to restore full service quickly, coupled with the need to maintain compliance with internal service level agreements, SLAs, and potentially external regulatory requirements for service availability, adds significant professional challenge. The LTM specialist must balance immediate troubleshooting with a systematic, evidence-based approach to avoid introducing further instability or overlooking a critical underlying issue. Correct approach analysis. The correct approach involves a methodical investigation that leverages the diagnostic capabilities of the BIG/IP LTM. This begins with verifying the health of the pool members and the virtual server configuration, as these are fundamental to traffic distribution. The next crucial step is to examine the LTM's logs, specifically the connection logs and event logs, for any anomalies or error messages that correlate with the reported user experience issues. Analyzing traffic statistics, such as connection counts, packet drops, and latency metrics, provides quantitative data to identify patterns or deviations from normal operation. Furthermore, utilizing the LTM's built-in troubleshooting tools, like packet captures, TCP dump, and connection table analysis, allows for granular inspection of network traffic and state. This comprehensive, data-driven approach ensures that the diagnosis is based on observable evidence and the LTM's operational state, aligning with best practices for system maintenance and troubleshooting. It also implicitly supports regulatory compliance by ensuring the system is operating as intended and that any deviations are promptly identified and addressed, thereby minimizing service disruption. Incorrect approach is analysis. One incorrect approach would be to immediately restart services or reboot the LTM appliance without a clear diagnostic rationale. This is a brute force method that can mask the underlying problem, making future diagnosis more difficult, and could lead to further service interruptions. From a regulatory and compliance perspective, this approach fails to demonstrate due diligence in identifying and resolving the root cause, potentially violating internal policies or SLAs that require systematic problem resolution. Another incorrect approach would be to solely rely on user reports without independently verifying the LTM status and traffic flow. While user feedback is valuable, it is subjective and may not accurately reflect the technical state of the LTM. Without correlating user complaints with LTM metrics and logs, the troubleshooting effort could be misdirected, leading to wasted time and resources. This lack of objective verification can also be problematic from a compliance standpoint, as it suggests an inability to provide auditable evidence of system health and performance. A third incorrect approach would be to make configuration changes to the virtual server or pool settings based on assumptions rather than diagnostic findings. Uninformed configuration changes can introduce new issues or exacerbate existing ones, leading to further instability and potential service outages. This is a direct violation of sound operational practices and could have significant regulatory implications if it leads to a breach of service availability commitments. Professional reasoning. Professionals in this role should adopt a structured troubleshooting methodology. This involves 1. Understanding the reported problem and its impact. 2. Verifying the current state of the system and its components. 3. Gathering objective data through logs, statistics, and diagnostic tools. 4. Forming hypotheses based on the collected data. 5. Testing hypotheses through targeted investigations or controlled changes. 6. Implementing solutions based on confirmed root causes. 7. Documenting findings and resolutions. This systematic process ensures that troubleshooting is efficient, effective, and defensible, upholding professional standards and regulatory obligations. Question 6. Comparative studies suggest that intermittent application performance issues can stem from various points in the network path. A critical e-commerce application hosted behind a BIGIP local traffic manager, LTM, is experiencing sporadic slowdowns and occasional transaction failures. Users report that the problem is not constant but occurs at unpredictable intervals. As the LTM specialist, what is the most effective initial diagnostic step to isolate the source of this performance degradation? Option A. Review the BIGIP LTM's virtual server status and the health of its associated pool members, paying close attention to any pool members that are marked as down or are experiencing frequent status changes. Option B. Immediately restart the web server processes on all backend application servers to clear any potential resource contention. Option C. Initiate a full packet capture on the BIGIP LTM's external interface to analyze traffic flow patterns during the reported incidents. Option D. Examine the application logs on the backend servers for any specific error messages related to transaction processing or database connectivity. The correct answer is C. Initiate a full packet capture on the BIGIP LTM's external interface to analyze traffic flow patterns during the reported incidents. Explanation. Scenario analysis. This scenario presents a common challenge in network operations, a critical application experiencing intermittent performance degradation. The difficulty lies in isolating the root cause when multiple components, including the BIGIP LTM, application servers, and network infrastructure, are potential culprits. The pressure to restore service quickly, coupled with the complexity of the LTM's configuration and its interaction with other systems, demands a systematic and informed troubleshooting approach. The professional challenge is to move beyond assumptions and apply a structured methodology to identify the actual problem without causing further disruption. Correct approach analysis. The correct approach involves a methodical examination of the BIGIP LTM's health and configuration, specifically focusing on the health of the virtual server and its associated pool members. This aligns with best professional practices for LTM maintenance and troubleshooting. By first verifying the virtual server's status and then checking the health of individual pool members, The administrator can quickly determine if the issue lies within the LTM's ability to direct traffic, or if the problem resides on the back-end servers themselves. This systematic approach minimizes the risk of misdiagnosis and ensures that troubleshooting efforts are directed efficiently. This is consistent with the general principles of IT service management and operational best practices, which emphasize a layered approach to problem resolution, starting with the most immediate point of traffic ingress. Incorrect approach is analysis. One incorrect approach is to immediately focus on the application code or individual server configurations without first validating the LTM's role. This bypasses a critical layer of the traffic management infrastructure and can lead to wasted effort if the LTM is misconfigured or experiencing issues. This approach fails to adhere to a logical troubleshooting methodology and could delay resolution. Another incorrect approach is to indiscriminately restart services or reboot devices without a clear understanding of the potential impact or the specific problem being addressed. This can lead to service interruptions for other applications or users and may not resolve the underlying issue, potentially exacerbating the situation. This is a reactive and potentially disruptive action that lacks the analytical rigor required for professional troubleshooting. A third incorrect approach is to solely rely on external monitoring tools without correlating their findings with the internal state of the BIGIP LTM. While external tools provide valuable insights, they may not capture the nuances of LTM-specific issues such as connection table exhaustion, resource utilization, or specific health monitor failures that are visible within the LTM itself. This approach risks overlooking critical internal LTM diagnostics. Professional reasoning. Professionals should adopt a structured, layered troubleshooting methodology. This begins with verifying the health and configuration of the traffic management layer, BIGIP LTM, before delving into the application or individual server layers. Key steps include 1. Confirming the status of the virtual server and its associated pool. 2. Examining the health status of individual pool members. 3. Reviewing LTM logs for relevant error messages. 4. Analyzing LTM resource utilization, CPU memory connection tables. 5. If LTM health is confirmed, then proceed to investigate backend server health, application logs, and network connectivity between the LTM and the servers. This systematic process ensures that the most likely causes are investigated first, minimizing downtime and preventing unnecessary changes to the environment. Question 7. Governance review demonstrates that a critical customer-facing application, managed by the BIGIP Local Traffic Manager, LTM, is experiencing intermittent periods of significant slowness. Users report that the application becomes unresponsive for several minutes at a time, with the issue occurring unpredictably throughout the day. The LTM configuration includes multiple virtual servers, pools of backend web servers, SSL offloading. What is the most appropriate initial troubleshooting approach to diagnose the root cause of this intermittent application slowness? Option A. Analyze BIGIP LTM logs for error messages and connection statistics, and simultaneously check the health and resource utilization of the backend web servers. Option B. Immediately restart the BIGIP LTM services to clear any potential transient issues affecting the load balancer. Option C. Focus solely on examining the network firewall logs and routing tables between the LTM and the backend servers for any packet drops or latency. Option D. Begin making incremental adjustments to the LTM's SSL profile settings and persistence configurations to see if performance improves. The correct answer is A. Analyze BIGIP LTM logs for error messages and connection statistics, and simultaneously check the health and resource utilization of the backend web servers. Explanation. Scenario analysis. This scenario presents a common challenge in network operations where a critical application's performance is degrading, impacting user experience and potentially business operations. The challenge lies in isolating the root cause of the intermittent slowness within a complex LTM environment. The intermittent nature of the issue makes it difficult to reproduce and diagnose, requiring a systematic and data-driven approach. Furthermore, the pressure to restore service quickly can lead to hasty decisions, potentially exacerbating the problem or introducing new ones. The need to balance immediate resolution with long-term stability and adherence to operational best practices is paramount. Correct approach analysis. The correct approach involves a methodical investigation starting with the most probable and easily verifiable causes. This begins with examining LTM logs for any specific error messages or patterns coinciding with the reported slowness. Simultaneously, checking the health of the backend servers and their resource utilization, CPU, memory, network, is crucial, as server-side issues are a frequent cause of application performance degradation. If these initial checks yield no clear answers, the next step is to analyze LTM connection statistics and performance metrics, e.g., connection rates, latency, packet loss, to identify any anomalies at the load balancer level. This systematic, layered approach, starting from the application's perspective and moving down to the network infrastructure, is best professional practice because it aligns with standard IT troubleshooting methodologies and ensures that all potential points of failure are considered in a logical order. It prioritizes data-driven decision-making, minimizing guesswork and reducing the risk of misdiagnosis. This approach also implicitly adheres to operational guidelines that emphasize proactive monitoring and systematic problem resolution to maintain service availability and performance. Incorrect approaches analysis. One incorrect approach would be to immediately begin making configuration changes to the LTM, such as adjusting persistence profiles or SSL settings, without first gathering sufficient diagnostic data. This is a regulatory and ethical failure because it violates the principle of informed decision-making and could lead to unintended consequences, such as disrupting other services or further degrading performance. It demonstrates a lack of due diligence and a disregard for the potential impact of changes on the overall system. Another incorrect approach would be to solely focus on the network infrastructure, such as checking firewall logs or routing tables, without considering the application or the LTM's role. While network issues can cause slowness, this approach is flawed because it ignores the LTM's specific functions in managing traffic and its potential to be the bottleneck or the point of misconfiguration. This narrow focus can lead to a prolonged resolution time and a failure to address the actual root cause, which might lie within the LTM's configuration or its interaction with the backend servers. This represents a failure in comprehensive troubleshooting and can be seen as a dereliction of duty in maintaining the LTM's intended functionality. A third incorrect approach would be to simply restart the LTM service or reboot the BIGIP device as a first step. While a reboot can sometimes resolve transient issues, it is a blunt instrument that bypasses the diagnostic process. This is professionally unacceptable because it is a reactive measure that does not identify the underlying problem. It can lead to service interruptions and does not contribute to understanding or preventing future occurrences, which is a core responsibility of a specialist. This approach lacks the analytical rigor expected and can be seen as an abdication of the troubleshooting responsibility. Professional reasoning. Professionals should adopt a structured troubleshooting methodology that begins with understanding the reported symptoms and their impact. This involves gathering information from users and monitoring systems. The next step is to form hypotheses about potential causes, prioritizing those that are most likely and easiest to test. This is followed by systematic testing and data collection, starting with the most accessible layers of the system, application, LTM, servers, network. Based on the evidence gathered, the hypothesis is either confirmed or refuted, leading to the next set of actions. This iterative process of hypothesize, test, and refine is crucial for efficient and effective problem resolution. In situations involving critical systems like LTM, adherence to established operational procedures, change management protocols, and thorough documentation is essential to ensure accountability and maintain system integrity. Question 8. To address the challenge of intermittent, unpredictable application performance degradation on a critical web service managed by a BIGIP LTM, which troubleshooting methodology should a BIGIP local traffic manager specialist prioritize to ensure minimal disruption and accurate root cause identification? Option A. Implement aggressive rate limiting and connection limits across all virtual servers to prevent potential overload, without first identifying the specific cause of the degradation. Option B. Systematically analyze BIGIP LTM logs, connection table, and performance metrics for patterns correlating with reported incidents, while simultaneously reviewing recent configuration changes and external network factors. Option C. Immediately revert the BIGIP LTM configuration to a known stable state from several weeks prior, assuming a recent change introduced the issue. Option D. Focus troubleshooting efforts solely on the application servers, as the BIGIP LTM is a network device and unlikely to be the source of application-level performance problems. The correct answer is B. Systematically analyze BIGIP LTM logs, connection table, and performance metrics for patterns correlating with reported incidents, while simultaneously reviewing recent configuration changes and external network factors. Explanation: this scenario presents a professional challenge due to the critical nature of network availability and the potential for data integrity issues. The BIGIP LTM specialist is tasked with maintaining a complex traffic management system, and any misconfiguration or troubleshooting misstep can lead to significant service disruption, impacting business operations and potentially customer trust. The need for a systematic and evidence-based approach is paramount, especially when dealing with intermittent and difficult-to-produce issues. The correct approach represents best professional practice because it prioritizes a thorough understanding of the system's baseline behavior and the specific symptoms observed. By leveraging the BIGIP's robust logging and monitoring capabilities, the specialist can gather objective data to pinpoint the root cause. This aligns with professional standards of diligence and competence, ensuring that actions taken are informed and justified. Furthermore, adhering to established troubleshooting methodologies, such as the OSI model or a layered approach, promotes efficiency and reduces the risk of introducing new problems. This methodical process is implicitly supported by industry best practices for IT service management, which emphasize root cause analysis and preventative measures. An incorrect approach that involves making broad, sweeping configuration changes without a clear hypothesis or supporting data is professionally unacceptable. Such actions can exacerbate the problem, lead to unintended consequences, and make subsequent troubleshooting more difficult. This demonstrates a lack of due diligence and a failure to apply systematic problem-solving techniques. Another incorrect approach, such as relying solely on anecdotal evidence or the hunch of another team member without independent verification, introduces a high degree of risk. This bypasses the critical step of objective data collection and analysis, potentially leading to misdiagnosis and ineffective solutions. It also fails to establish a clear audit trail for troubleshooting actions, which is crucial for accountability and future reference. The professional decision-making process for similar situations should involve a structured approach. 1. Clearly define the problem and its impact. 2. Gather all available information, including logs, monitoring data, and user reports. 3. Formulate a hypothesis based on the gathered evidence. 4. Test the hypothesis through controlled changes or further investigation. 5. Document all steps taken and their outcomes. 6. If the problem persists, revisit the hypothesis or formulate a new one based on updated information. 7. Escalate or consult with subject matter experts when necessary. Question 9. Strategic planning requires a proactive approach to identifying and resolving application performance issues. An organization's critical e-commerce application, hosted behind a BIGIP LTM, has begun experiencing intermittent slowdowns and occasional transaction failures, impacting user experience and revenue. The LTM administrator is tasked with diagnosing and rectifying the problem. Which of the following troubleshooting methodologies represents the most effective and professionally responsible initial approach? Option A. Initiate a full system reboot of the BIGIP LTM appliance to clear any potential internal states that might be causing the issue. Option B. Immediately begin modifying application server configurations and restarting services on the backend servers to see if performance improves. Option C. Focus exclusively on verifying network connectivity between the BIGIP LTM and the application servers, checking ping and traceroute results. Option D. Systematically examine the BIGIP LTM's virtual server configuration, pool health, pool member status, and connection statistics for any anomalies or errors. Correct answer is B. Immediately begin modifying application server configurations and restarting services on the backend servers to see if performance improves. Explanation: scenario analysis. This scenario presents a common challenge in network operations, a critical application experiencing intermittent performance degradation. The difficulty lies in isolating the root cause, which could stem from various layers of the BIGIP LTM configuration, the underlying network, or the application servers themselves. The pressure to restore service quickly, coupled with the potential impact on business operations, necessitates a systematic and informed troubleshooting approach. The challenge is amplified by the need to adhere to operational best practices and potentially regulatory compliance, ensuring that troubleshooting steps do not inadvertently introduce further instability or violate security policies. Correct approach analysis. The correct approach involves a methodical, layered investigation, starting with the most probable and easily verifiable LTM configurations. This aligns with best practices for LTM maintenance and troubleshooting, emphasizing a top-down or bottom-up approach depending on the symptoms. By examining the virtual server, pool, and pool members, a specialist can quickly identify misconfigurations, health check failures, or resource exhaustion at the LTM level. This systematic process minimizes disruption and efficiently narrows down the potential causes. This approach is professionally sound as it prioritizes the stability and availability of the LTM, which is a critical component of the application delivery infrastructure. It also aligns with the principle of least privilege and impact, ensuring that changes are made deliberately and with a clear understanding of their consequences. Incorrect approaches analysis. One incorrect approach would be to immediately begin making broad configuration changes to the application servers without first thoroughly investigating the LTM. This is professionally unacceptable because it bypasses the LTM's role as a traffic manager and potential point of failure. It risks introducing further complexity and making it harder to pinpoint the actual issue. From a regulatory or compliance perspective, unauthorized or undocumented changes to production systems can lead to audit failures and security vulnerabilities. Another incorrect approach would be to focus solely on network connectivity between the LTM and the servers, ignoring the LTM's own health and configuration. While network issues can cause performance problems, the LTM itself has numerous internal states and configurations that can impact traffic flow and application responsiveness. Neglecting to examine the LTM's health checks, connection tables, or resource utilization is a failure to perform a comprehensive investigation and can lead to wasted time and resources. This could also be seen as a failure to maintain the integrity of the managed environment, which may have compliance implications depending on the industry. A third incorrect approach would be to restart services or reboot devices without a clear understanding of the impact or a plan to revert. While sometimes necessary, this is a blunt instrument that can mask the underlying problem and cause further downtime. It is not a troubleshooting step, but rather a last resort. Professionally, this demonstrates a lack of analytical skill and can lead to significant service disruption, potentially violating service-level agreements, SLAs, and incurring financial penalties. Professional reasoning. Professionals should adopt a structured troubleshooting methodology. This typically involves 1. Gathering information, understanding the symptoms, scope, and impact. 2. Forming a hypothesis. Based on the gathered information, identify potential causes. 3. Testing the hypothesis. Systematically verify or refute the hypothesis through targeted checks and configurations. 4. Implementing a solution. Once the root cause is identified, apply the appropriate fix. 5. Verifying the solution. Confirm that the issue is resolved and monitor for recurrence. In the context of LTM, this means starting with the LTM's configuration and health, then moving to the network, and finally the application servers, always documenting steps and their outcomes. Question 10. Governance review demonstrates that the BIGIP LTM configuration for a critical financial trading platform has experienced intermittent performance degradation, leading to transaction delays. The LTM team is under immense pressure to resolve the issue immediately to minimize financial losses, which approach best balances the need for rapid resolution with regulatory compliance. Option A. Perform a series of rapid, unrecorded configuration adjustments on the production BIGIP LTM, experimenting with different load balancing algorithms and persistence profiles until the performance issue is resolved, and then document the final working configuration. Option B. Temporarily disable advanced security features and reduce logging levels on the BIGIP LTM to expedite troubleshooting, with the intention of re-enabling them once the performance issue is identified and resolved. Option C. Immediately implement emergency configuration changes on the production BIGIP LTM, focusing on disabling non-essential monitoring and adjusting traffic shaping policies to prioritize trading traffic, with a plan to document these changes retrospectively after service is fully restored. Option D. Initiate a controlled troubleshooting process that involves detailed logging of all diagnostic steps, engaging the Change Advisory Board for emergency approval of any proposed configuration modifications, and ensuring all changes are documented with clear rollback procedures before implementation. The correct answer is C. Immediately implement emergency configuration changes on the production BIGIP LTM, focusing on disabling non-essential monitoring and adjusting traffic shaping policies to prioritize trading traffic, with a plan to document these changes retrospectively after service is fully restored. Explanation. Scenario analysis. This scenario presents a common challenge in regulated environments where network infrastructure directly impacts the availability and integrity of financial services. The core difficulty lies in balancing the need for rapid incident response with the stringent requirements for auditability, change control, and data integrity mandated by financial regulations. A misstep in troubleshooting can lead to regulatory noncompliance, fines, and reputational damage, making a methodical and compliant approach paramount. The pressure to restore service quickly can tempt engineers to bypass established procedures, creating significant risk. Correct approach analysis. The correct approach prioritizes adherence to established change management and incident response protocols, which are foundational to regulatory compliance in financial services. This involves documenting all actions, obtaining necessary approvals for changes, and ensuring that any emergency modifications are retroactively documented and reviewed. This methodology ensures that the network state is auditable, that changes are traceable, and that the organization can demonstrate compliance with regulations like SOX, Sarbanes-Oxley Act, or similar financial oversight frameworks that require robust internal controls over financial reporting, which includes IT systems. By following these procedures, the organization maintains the integrity of its systems and provides evidence of due diligence to regulators. Incorrect approaches analysis. Implementing emergency changes without proper documentation or subsequent approval directly violates change management policies and regulatory requirements for audit trails. This creates a significant risk of noncompliance, as it becomes impossible to demonstrate to auditors or regulators how and why a change was made, or its impact on system integrity. It also bypasses risk assessment, potentially introducing new vulnerabilities or service disruptions. Performing troubleshooting steps that involve disabling security features or altering logging configurations without explicit authorization and documented justification is a severe regulatory failure. Such actions can compromise data security and privacy, leading to breaches that incur substantial penalties under data protection laws. Furthermore, it undermines the integrity of audit logs, which are critical for forensic analysis and regulatory investigations. Making configuration changes directly on the production BIGIP LTM without a documented rollback plan or testing in a staging environment is a high-risk practice. While it might seem faster in the short term, it significantly increases the likelihood of unintended consequences, prolonged outages, and data corruption. This lack of foresight and planning demonstrates a disregard for business continuity and disaster recovery principles, which are often implicitly or explicitly required by financial regulations to ensure the resilience of critical systems. Professional reasoning. Professionals in this domain must adopt a decision-making process that integrates technical expertise with a strong understanding of the regulatory landscape. When faced with an incident, the first step is to assess the impact and urgency. If immediate action is required, the focus should be on the least intrusive, most reversible steps that can be taken within existing emergency procedures. All actions, even those taken under pressure, must be logged in real time or immediately thereafter. A critical part of the process is to ensure that any emergency changes are followed by a formal review and documentation process, including a post-incident analysis, to identify lessons learned and update procedures. This ensures that while service is restored, the organization's compliance posture is maintained and strengthened. Question 11. Compliance review shows that encrypted traffic passing through the BIGIP local traffic manager is not being inspected for sensitive data exfiltration, potentially violating data protection regulations. What is the most appropriate action to ensure regulatory adherence while maintaining optimal network performance? Option A. Disable SSL/TLS decryption on the BIGIP LTM to prioritize network performance and reduce processing load. Option B. Rely solely on endpoint security solutions to detect and prevent sensitive data exfiltration from encrypted traffic. Option C. Implement SSL/TLS decryption and inspection on each individual backend server hosting the applications. Option D. Configure the BIGIP LTM to perform SSL/TLS decryption and inspection using SSL profiles and policies, allowing for content examination before re-encryption. The correct answer is D. Configure the BIGIP LTM to perform SSL/TLS decryption and inspection using SSL profiles and policies, allowing for content examination before re-encryption. Explanation. Scenario analysis. This scenario presents a common challenge in network security and compliance, ensuring that sensitive data transmission adheres to regulatory mandates while maintaining operational efficiency. The core difficulty lies in balancing the need for robust encryption, as dictated by regulations, with the potential performance impact of SSL/TLS decryption and re-encryption on a BIGIP LTM. The compliance review highlights a potential gap, requiring a proactive and informed response to avoid penalties and data breaches. The challenge is to identify the most effective and compliant method for inspecting encrypted traffic without compromising security or performance beyond acceptable thresholds. Correct approach analysis. The correct approach involves leveraging the BIGIP LTM's capabilities for SSL/TLS decryption and inspection, specifically through the use of SSL profiles and policies. This allows the LTM to examine the content of encrypted traffic for compliance violations or security threats before re-encrypting it and forwarding it to its destination. This method directly addresses the compliance requirement by enabling traffic inspection, while maintaining the integrity of the encrypted session from the client's perspective to the LTM and from the LTM to the server. It represents best professional practice because it utilizes the intended functionality of the LTM for security and compliance monitoring, aligning with regulatory frameworks that often mandate visibility into network traffic, even when encrypted. This approach is efficient as it centralizes decryption and inspection at the LTM, avoiding the need to decrypt traffic on individual servers. Incorrect approach is analysis. One incorrect approach is to simply disable SSL/TLS decryption and inspection on the BIGIP LTM to improve performance. This is a significant regulatory and ethical failure. Many regulations, such as those pertaining to data privacy and financial transactions, require organizations to monitor and protect sensitive data in transit. Disabling inspection means that any malicious content or policy violations within encrypted traffic would go undetected, leading to non-compliance, potential data breaches, and severe penalties. It also fails to uphold the professional responsibility to secure network traffic. Another incorrect approach is to implement decryption and inspection on individual backend servers. While this might technically allow for inspection, it is operationally inefficient, difficult to manage at scale, and introduces security risks by distributing decryption keys across multiple servers. It also bypasses the centralized control and visibility offered by the LTM, making it harder to enforce consistent security policies and respond to incidents. This approach is professionally unsound as it deviates from best practices for centralized traffic management and security. A third incorrect approach is to rely solely on endpoint security solutions for compliance without addressing the encrypted traffic flowing through the LTM. Endpoint solutions are crucial, but cannot inspect traffic traversing the network at the LTM level. This creates a blind spot in network visibility, leaving the organization vulnerable to threats that exploit encrypted channels and failing to meet regulatory requirements for network traffic monitoring. Professional reasoning. Professionals facing such a compliance review must adopt a systematic decision-making process. First, thoroughly understand the specific regulatory requirements applicable to the organization's data and industry. Second, assess the capabilities of the existing BIGIP LTM infrastructure, including its SSL/TLS handling features and performance characteristics. Third, evaluate potential solutions, prioritizing those that offer a balance of security, compliance, and performance. The decision should always be guided by the principle of least privilege and the need for comprehensive visibility and control over network traffic. When in doubt, consulting with security and compliance experts, as well as F5 documentation, is essential. The goal is to implement a solution that not only meets immediate compliance needs, but also enhances the overall security posture of the network. Question 12. Consider a scenario where a BIGIP LTM specialist is tasked with applying a critical security patch to the LTM appliance. The patch requires a reboot of the device. The organization operates a 24/7 e-commerce platform with peak traffic occurring between 9 a.m. and 5 p.m. local time on weekdays. What is the most appropriate approach to apply this security patch? Option A. Initiate the patch application and reboot during the weekday afternoon, assuming that most users will have completed their critical transactions by then. Option B. Apply the patch and initiate the reboot immediately during the busiest part of the weekday, as security patches are always the highest priority. Option C. Inform the relevant business units that a reboot is imminent and proceed with the patch application and reboot during the peak business hours to minimize the delay in patch deployment. Option D. Schedule the patch application and reboot during the late evening or early morning hours on a weekend, ensuring ample time for testing and validation before the next business day begins. The correct answer is D. Schedule the patch application and reboot during the late evening or early morning hours on a weekend, ensuring ample time for testing and validation before the next business day begins. Explanation. This scenario presents a professional challenge due to the critical nature of network availability and the potential for service disruption. The LTM specialist must balance the need for proactive maintenance with the imperative to minimize downtime, especially in a production environment. The complexity arises from understanding the interdependencies of network services and the potential impact of configuration changes on user experience and business operations. Careful judgment is required to select a maintenance window and methodology that mitigates risk effectively. The correct approach represents best professional practice because it prioritizes minimizing impact on end users and business operations. Scheduling maintenance during off-peak hours is a standard industry practice that aligns with the principle of responsible service management. Thorough testing and validation post-maintenance ensure that the LTM is functioning as expected and that no unintended consequences have arisen. This proactive and controlled approach demonstrates a commitment to service continuity and adherence to operational best practices, which are implicitly expected in professional IT environments. An incorrect approach of performing maintenance during peak business hours without prior notification or a rollback plan would be a significant regulatory and ethical failure. This demonstrates a disregard for service-level agreements, SLAs, and a lack of consideration for the business impact, potentially leading to financial losses and reputational damage. It violates the implicit ethical obligation to maintain system stability and availability for users. Another incorrect approach of implementing changes without a documented rollback strategy is also professionally unacceptable. This indicates a failure to adequately plan for contingencies and a lack of risk management. In the event of an issue, the inability to quickly revert to a stable state would prolong downtime and exacerbate the problem, violating professional standards of diligence and preparedness. A further incorrect approach of relying solely on automated deployment without human oversight for critical configuration changes is risky. While automation is valuable, critical changes require a human element for validation and to identify subtle issues that automation might miss. This approach lacks the necessary due diligence and could lead to unforeseen problems, demonstrating a failure in professional judgment and risk assessment. The professional reasoning process for similar situations should involve a comprehensive risk assessment, including identifying potential impacts, likelihood of occurrence, and severity of consequences. This should be followed by developing a detailed maintenance plan that includes a clear schedule, specific steps, testing procedures, and a robust rollback strategy. Communication with stakeholders, including end users and management, about planned maintenance is also crucial. Finally, post-maintenance verification and documentation are essential for continuous improvement and accountability. Question 13. The investigation demonstrates that a critical BIGIP LTM service experienced intermittent failures, impacting customer access. The LTM specialist identified a potential configuration issue that could be resolved with a temporary workaround, but a full, permanent fix would require extensive testing and a formal change request process that could take several days. The pressure from management to restore full service immediately is immense, and the specialist is aware that deviating from the standard change control procedures carries inherent risks. What is the most appropriate course of action for the LTM specialist to take in this situation, balancing operational demands with security and compliance requirements? Option A. Implement the temporary workaround without any formal documentation or approval, as the immediate need to restore service outweighs the procedural requirements. Option B. Refuse to implement any changes until the full, formal change request process and risk assessment for the permanent fix are completed, even if it means extended service disruption. Option C. Implement the temporary workaround immediately to restore service, thoroughly documenting the change, and submitting a formal change request for the permanent fix as soon as possible. Option D. Implement the temporary workaround, document it, and then seek retroactive approval from management, assuming they will understand the urgency. The correct answer is C. Implement the temporary workaround immediately to restore service, thoroughly documenting the change, and submitting a formal change request for the permanent fix as soon as possible. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the potential conflict between immediate operational needs and the long-term security implications of a critical system. The pressure to restore service quickly can lead to shortcuts that compromise security best practices. The LTM specialist is faced with a decision that has both technical and ethical dimensions, requiring careful judgment to balance competing priorities. The core challenge lies in adhering to established security protocols and regulatory compliance when faced with urgent demands. Correct approach analysis. The correct approach prioritizes adherence to established security policies and regulatory frameworks, even under pressure. This aligns with the principles of responsible system administration and data protection. By documenting the deviation and seeking formal approval, the LTM specialist upholds the integrity of the security posture and ensures that any exceptions are managed transparently and with appropriate oversight. This proactive approach mitigates future risks and demonstrates a commitment to compliance, which is paramount in regulated environments. The specific regulatory framework for this exam, implied to be US-based, given common LTM contexts, would likely emphasize principles found in NIST guidelines, PCI DSS, or HIPAA, all of which mandate documented change control and risk assessment for security-related modifications. Incorrect approaches analysis. One incorrect approach involves bypassing the formal change control process entirely and implementing the fix without documentation or approval. This is a direct violation of most IT governance frameworks and regulatory requirements that mandate auditable trails for system changes. It creates a significant security risk by leaving the system in a state that deviates from its baseline configuration without a clear record of why or how it was altered. This could lead to compliance failures and make troubleshooting future issues more difficult. Another incorrect approach is to implement the fix and then attempt to retroactively document it without seeking prior approval. While documentation is important, the lack of pre-approval for a security-related change is problematic. It suggests a disregard for the established risk management process. Regulatory bodies often require that changes impacting security be reviewed and approved before implementation to ensure that potential risks are adequately assessed and mitigated. A third incorrect approach is to refuse to implement any fix until a full, formal risk assessment is completed, even if it means prolonged downtime. While risk assessment is crucial, an overly rigid adherence without considering the immediate impact and potential for a temporary documented workaround can be detrimental. The ethical consideration here is the balance between absolute security and the operational impact on users or customers, which might necessitate a pragmatic, albeit carefully managed, approach. However, in this specific context, the primary failure is the lack of a mechanism to address urgent needs within a controlled framework. Professional reasoning. Professionals in this role should employ a decision-making framework that integrates technical expertise with an understanding of regulatory obligations and ethical responsibilities. This involves 1. Understanding the immediate technical problem and its impact. 2. Identifying relevant security policies and regulatory requirements. 3. Assessing the risks associated with different courses of action. 4. Communicating with stakeholders to understand business impact and urgency. 5. Following established change management procedures, including seeking appropriate approvals for deviations. 6. Documenting all actions and decisions thoroughly. When faced with urgent situation, the process should allow for expedited review and approval of necessary exceptions, rather than outright bypass. Question 14. Upon reviewing the BIGIP Local Traffic Manager, LTM, logs and observing a sudden increase in application errors and client connection failures for a critical web service, what is the most appropriate initial troubleshooting step to diagnose and resolve the issue? Option A. Proceed to modify the health monitor settings for the pool members to see if that resolves the connection issues. Option B. Immediately reboot the BIGIP LTM device to clear any potential transient issues. Option C. Contact the application development team to inquire about recent code deployments without first examining the LTM's operational status. Option D. Analyze the BIGIP LTM logs for error messages, connection statistics, and recent configuration changes related to the affected application virtual server. Correct answer is B. Immediately reboot the BIGIP LTM device to clear any potential transient issues. Explanation. This scenario presents a common challenge in network operations, where a critical service outage impacts business operations, necessitating rapid troubleshooting and resolution. The professional challenge lies in balancing the urgency of restoring service with the need to adhere to established operational procedures and security protocols, particularly when dealing with a complex system like BIGIP LTM. The pressure to resolve the issue quickly can lead to shortcuts that might compromise security or introduce further instability. The correct approach emphasizes a systematic, data-driven troubleshooting methodology. By first examining the BIGIP LTM logs and configuration for anomalies related to the affected application, the administrator can efficiently pinpoint the root cause. This aligns with best professional practices for network maintenance and troubleshooting, which prioritize understanding the system's state before making changes. Specifically, consulting the BIGIP LTM documentation and knowledge base for known issues or common causes of such symptoms is a proactive and informed step. This methodical approach minimizes the risk of introducing new problems and ensures that any remediation is targeted and effective. An incorrect approach that immediately involves making configuration changes without a clear understanding of the cause is professionally unacceptable. This could lead to unintended consequences, such as further service degradation or security vulnerabilities, violating the principle of least privilege and potentially breaching service level agreements, SLAs. Another incorrect approach, such as rebooting the BIGIP LTM device without prior investigation, is a brute force method that can mask the underlying issue and make subsequent diagnosis more difficult. It also risks disrupting other services that might be running on the same device. Furthermore, failing to document the troubleshooting steps and findings is a significant professional and ethical lapse, hindering future problem resolution and knowledge sharing within the team. The professional decision-making process for similar situations should involve a structured approach. 1. Assess the impact and gather initial information. 2. Consult available logs and monitoring tools. 3. Formulate hypotheses based on the data. 4. Test hypotheses systematically, starting with non-disruptive checks. 5. Implement changes cautiously with rollback plans. 6. Document all actions and outcomes. 7. Communicate effectively with stakeholders. Question 15. Market research demonstrates that intermittent performance issues with a critical customer-facing application are impacting user experience and revenue. The application relies heavily on the BIGIP LTM for load balancing and SSL offloading. The LTM team has been tasked with identifying and resolving the root cause of these performance degradations, which appear to be sporadic and difficult to reproduce consistently. What is the most professional and compliant approach to troubleshooting this issue? Option A. Temporarily disable SSL offloading on the LTM for the affected application to rule out SSL processing as the bottleneck, without first analyzing existing LTM performance data or consulting with security teams. Option B. Immediately implement aggressive, unproven configuration changes to LTM profiles and persistence settings to see if any resolve the issue, prioritizing speed over potential disruption. Option C. Systematically gather and analyze LTM logs, connection statistics, and relevant system metrics, correlating them with application performance data, while consulting with application owners to isolate the problem before making any configuration changes. Option D. Rely solely on user-reported symptoms and application team feedback to make educated guesses about the LTM configuration and apply quick fixes without extensive data validation. The correct answer is B. Immediately implement aggressive, unproven configuration changes to LTM profiles and persistence settings to see if any resolve the issue, prioritizing speed over potential disruption. Explanation. This scenario presents a common challenge in network operations, balancing performance optimization with the need for consistent, predictable service delivery, especially when dealing with a critical application. The professional challenge lies in identifying the root cause of intermittent performance degradation without disrupting ongoing business operations or introducing new risks. The stakeholder perspective is crucial here, as different teams, e.g., application owners, security infrastructure, will have varying priorities and tolerances for risk and downtime. The correct approach, which involves a phased, controlled troubleshooting methodology, represents best professional practice because it prioritizes minimizing impact on the production environment by starting with non-intrusive checks and progressively moving to more involved diagnostics. It allows for early detection of issues and rollback if necessary. This aligns with IT best practices for change management and incident response, ensuring that troubleshooting efforts are systematic and documented. In a regulated environment, this methodical approach is essential for demonstrating due diligence and adherence to operational standards, which can be critical during audits or incident reviews. An incorrect approach that immediately implements aggressive, unproven configuration changes without proper testing or rollback plans poses significant regulatory and ethical risks. Such actions could lead to extended outages, data corruption, or security vulnerabilities, violating service-level agreements, SLAs, and potentially breaching compliance requirements related to system availability and data integrity. For instance, making broad changes to LTM profiles or persistence settings without understanding their downstream impact could inadvertently affect other applications or introduce security loopholes, leading to non-compliance with data protection regulations or industry-specific standards. Another incorrect approach, such as solely relying on anecdotal evidence or user reports without systematic data collection and analysis, is professionally unsound. This can lead to misdiagnosis, wasted resources, and prolonged downtime. Ethically, it fails to uphold the responsibility to provide a reliable service. From a regulatory standpoint, it demonstrates a lack of a structured incident management process, which is often a requirement for maintaining certifications or meeting compliance mandates. A professional decision-making process for similar situations should involve 1. Clearly defining the problem and its impact. 2. Gathering all available data, logs, metrics, configuration. 3. Consulting with relevant stakeholders to understand their priorities and constraints. 4. Developing a troubleshooting plan with clear steps, expected outcomes, and rollback procedures. 5. Executing the plan in a controlled manner. And 6. Documenting all actions and their results. This structured approach ensures that troubleshooting is efficient, effective, and compliant with operational and regulatory requirements. Question 16. Examination of the data shows a recurring pattern of intermittent connectivity issues affecting a critical trading application hosted behind the BIGIP LTM. Business stakeholders are reporting significant financial losses due to transaction failures. The LTM specialist has observed unusual spikes in connection table entries during these periods. What is the most appropriate course of action for the BIGIP LTM specialist to take from a stakeholder perspective, considering the need for rapid resolution and minimal business impact? Option A. Immediately increase the connection limits on the relevant virtual server and pool members to accommodate the observed spikes and monitor for further issues. Option B. Initiate a rollback of the most recent LTM configuration changes, assuming they are the cause, and then proceed with a detailed investigation. Option C. Engage with key business stakeholders to understand the precise impact of the intermittent connectivity, gather detailed logs from application and server teams, and then systematically analyze LTM connection table data and relevant configuration settings to identify the root cause before proposing a solution. Option D. Temporarily disable the LTM's connection mirroring feature to reduce resource utilization, as this might be contributing to the connection table spikes, and observe the application's performance. Correct answer is A. Immediately increase the connection limits on the relevant virtual server and pool members to accommodate the observed spikes and monitor for further issues. Explanation. This scenario presents a professional challenge due to the critical nature of network availability for financial transactions and the potential for significant business impact if service is disrupted. The stakeholder perspective is crucial here, as different departments will have varying priorities and risk tolerances. The LTM specialist must balance technical best practices with business needs and regulatory compliance. The correct approach represents best professional practice because it prioritizes a structured, risk-averse methodology for troubleshooting. By engaging relevant stakeholders, gathering comprehensive data, and isolating the issue systematically, the specialist minimizes the risk of further disruption. This aligns with the principles of due diligence and responsible IT management, ensuring that changes are made with full awareness of potential consequences and with appropriate authorization. The focus on understanding the root cause before implementing a fix is paramount in maintaining service integrity. An incorrect approach that involves immediate, unverified configuration changes without stakeholder consultation or thorough analysis poses significant regulatory and ethical risks. In the context of financial services, where uptime and data integrity are paramount, such actions could lead to breaches of service-level agreements, SLAs, financial penalties, and reputational damage. Ethically, it demonstrates a lack of professionalism and disregard for the impact on the business and its customers. Furthermore, it could violate internal policies and potentially regulatory requirements related to IT operational resilience and incident management. Another incorrect approach, such as blaming external factors without sufficient evidence or attempting to mask the problem, is professionally unacceptable. This demonstrates a failure to take ownership and a lack of commitment to resolving the issue effectively. It can lead to prolonged downtime, increased costs, and a breakdown of trust between IT and business units. From a regulatory standpoint, misrepresenting the cause or impact of an incident can have severe consequences, including regulatory scrutiny and sanctions. The professional decision-making process for similar situations should involve a clear incident response plan. This includes immediate containment, thorough investigation, clear communication with stakeholders, root cause analysis, implementation of corrective actions with appropriate change control, and post-incident review. Prioritizing stakeholder communication and understanding their business impact is essential for making informed decisions that balance technical solutions with business continuity and regulatory compliance. Question 17. Performance analysis shows a critical customer-facing application is experiencing intermittent slowness and occasional timeouts. Users report inconsistent experiences, with some sessions performing adequately while others are significantly delayed. The LTM team has been alerted. What is the most appropriate initial troubleshooting step for the LTM specialist to take to diagnose the LTM's potential involvement in this performance degradation? Option A. Analyze the application server logs for errors, assuming the LTM is functioning as expected and the issue lies solely within the application. Option B. Review LTM connection table statistics for unusual spikes in connection counts, drop connections, or high latency on relevant virtual servers and pool members. Option C. Restart all LTM services and reboot the LTM devices to clear any potential transient issues. Option D. Immediately engage the application development team to investigate recent code deployments or known application-level bugs. The correct answer is B. Review LTM connection table statistics for unusual spikes in connection counts, dropped connections, or high latency on relevant virtual servers and pool members. Explanation. Scenario analysis. This scenario presents a common challenge in network operations where critical applications' performance degrades, impacting user experience and potentially business operations. The challenge lies in isolating the root cause of the performance issue within a complex LTM environment, especially when the issue appears intermittent or difficult to reproduce. The stakeholder perspective is crucial here, as different teams, application owners, network engineers, security teams, will have varying priorities and assumptions about the cause. The pressure to restore service quickly, coupled with the need for accurate diagnosis to prevent recurrence, makes this a high-stakes situation requiring methodical troubleshooting. Correct approach analysis. The correct approach involves a systematic, data-driven investigation that begins with understanding the scope and impact of the problem from the user's perspective, and then progressively drills down into the LTM configuration and traffic flow. This aligns with best practices for network troubleshooting and incident response, emphasizing evidence-based decision-making. By examining LTM logs, connection statistics, and health monitor status, the network engineer can identify patterns or anomalies that point towards the LTM's role in the performance degradation. This methodical approach ensures that potential LTM-related issues, such as misconfigured profiles, resource exhaustion on LTM devices, or incorrect pool member health, are thoroughly investigated before concluding that the LTM is not the cause. This is crucial for maintaining service availability and meeting service level agreements, SLAs, which are often implicitly or explicitly governed by regulatory frameworks requiring diligent service management. Incorrect approaches analysis, focusing solely on the application code without first verifying the LTM's health and configuration, is a premature conclusion. This approach risks overlooking LTM-related issues that could be directly causing or exacerbating application problems. It represents a failure to follow a structured troubleshooting methodology, potentially leading to wasted effort on the wrong area and delaying resolution. From a regulatory perspective, this could be seen as a failure to exercise due diligence in maintaining the availability and performance of critical services. Assuming the LTM is functioning correctly without any verification is a dangerous assumption. Network devices, especially load balancers, are complex and can experience subtle issues that impact application performance. This approach bypasses essential diagnostic steps and could lead to a prolonged outage or misdiagnosis. It demonstrates a lack of professional skepticism and a failure to adhere to established troubleshooting protocols, which are often implicitly tied to regulatory requirements for operational integrity. Immediately escalating the issue to the application development team without any initial LTM-specific investigation is also an inefficient and potentially incorrect approach. While collaboration is key, the LTM engineer has a responsibility to perform initial diagnostics within their domain. This premature escalation can lead to finger-pointing and delays, as the application team may then need to wait for the LTM team to confirm the LTM is not the issue. This reflects a failure in the incident management process and a lack of ownership in the initial troubleshooting phases. Professional reasoning. Professionals should adopt a layered troubleshooting approach, starting with the most likely or impactful points of failure and systematically eliminating possibilities. This involves 1. Understanding the reported problem and its impact. 2. Gathering initial data, logs, alerts, user reports. 3. Investigating the LTM's health, configuration, and traffic statistics. 4. Correlating LTM data with application behavior. 5. Collaborating with other teams' application, server, network as necessary, providing them with specific data points from the LTM investigation. This structured process ensures that all potential causes are considered and that the most efficient path to resolution is taken, minimizing downtime and meeting operational objectives. Question 18. Quality control measures reveal that users are experiencing intermittent application slowness and occasional timeouts for a critical business application managed by the BIGIP LTM. The LTM is configured with a default HTTP profile and a round-robin load balancing method across a pool of application servers. The application team reports no recent code deployments. What is the most effective initial troubleshooting approach to identify the root cause of the performance degradation? Option A. Verify the status of the BIGIP LTM self-IP and management interfaces. Review LTM logs for any critical errors, and confirm the health status of the application pool members and their associated health monitors. Option B. Implement aggressive performance tuning on the BIGIP LTM by increasing connection limits and reducing idle timeouts. Option C. Focus solely on verifying network connectivity between the BIGIP LTM and each application server using ping and traceroute. Option D. Immediately restart all application servers in the pool to clear any potential transient issues. The correct answer is A. Verify the status of the BIGIP LTM self-IP and management interfaces, review LTM logs for any critical errors, and confirm the health status of the application pool members and their associated health monitors. Explanation. Scenario analysis. This scenario presents a common challenge in network operations where a critical application's performance is degraded, impacting end users and potentially business operations. The challenge lies in quickly and accurately diagnosing the root cause within a complex LTM environment, while adhering to strict operational procedures and maintaining service availability. The pressure to restore service rapidly can lead to hasty decisions, making a systematic and evidence-based troubleshooting approach paramount. The stakeholder perspective is crucial, as the impact on users and business continuity must be prioritized. Correct approach analysis. The correct approach involves a methodical investigation starting with the most likely and impactful areas. This aligns with best practices for network troubleshooting and the principles of maintaining and troubleshooting BIGIP LTM. Specifically, examining the BIGIP LTM's health status, pool member status, and recent configuration changes provides immediate insights into potential LTM-level issues. Verifying the application's health checks and ensuring they accurately reflect the application's actual state is critical. If the LTM appears healthy and the application health checks are passing, the next logical step is to investigate the application servers themselves. This systematic approach minimizes disruption, avoids unnecessary changes, and focuses on evidence to pinpoint the problem efficiently. This aligns with the operational guidelines for maintaining LTM stability and performance, ensuring that troubleshooting efforts are directed towards the most probable causes first. Incorrect approaches analysis. Immediately restarting application servers without proper diagnosis is a common but often ineffective troubleshooting step. It can mask the underlying issue, leading to recurring problems, and may violate change management procedures if not properly documented and authorized. This approach fails to gather diagnostic data and relies on a brute force method that could disrupt other services or introduce new issues. Focusing solely on network connectivity between the LTM and the application servers, while a valid step in some troubleshooting scenarios, is premature if the LTM itself is not reporting issues and the application health checks are passing. This approach overlooks potential LTM configuration problems or application-level issues on the servers, leading to an incomplete diagnosis. Implementing aggressive performance tuning on the BIGIP LTM without understanding the root cause of the performance degradation is also problematic. This could involve making changes to connection limits, timeouts, or other performance-related settings without evidence that these are the actual bottlenecks. Such actions can destabilize the LTM or negatively impact other applications. Professional reasoning. Professionals should adopt a structured troubleshooting methodology. This typically involves 1. Understanding the reported problem and its impact. 2. Gathering information from all relevant sources, monitoring tools, user reports, LTM logs, configuration. 3. Forming hypotheses about potential causes. 4. Testing hypotheses systematically, starting with the most probable and least disruptive. 5. Implementing solutions based on confirmed causes. 6. Verifying the resolution and documenting the process. In this context, the LTM's health and configuration are the first points of investigation due to its role as the traffic manager. Question 19. Analysis of intermittent application performance degradation impacting users, where the BIGIP local traffic manager, LTM, is the primary traffic management device. What is the most appropriate initial troubleshooting approach to identify the root cause? Option A. Focus exclusively on examining the application code and backend server configurations for performance bottlenecks, assuming the LTM is functioning correctly. Option B. Initiate a full network packet capture on the BIGIP LTM and begin analyzing traffic patterns for anomalies without first checking basic LTM health. Option C. Immediately review BIGIP LTM logs for connection errors, health check failures, and resource utilization, while also verifying the health status and responsiveness of backend pool members from the LTM's perspective. Option D. Proceed directly to restarting the BIGIP LTM services, or rebooting the device to clear any potential transient issues. The correct answer is C. Immediately review BIGIP LTM logs for connection errors, health check failures, and resource utilization, while also verifying the health status and responsiveness of backend pool members from the LTM's perspective. Explanation. Scenario analysis. This scenario presents a common challenge in network operations. a critical application experiencing intermittent performance degradation. The difficulty lies in isolating the root cause within a complex LTM environment, especially when the issue is not a complete outage but a subtle, inconsistent impact. The pressure to restore full performance quickly, coupled with the potential for widespread user dissatisfaction and business impact, necessitates a systematic and evidence-based troubleshooting approach. The challenge is amplified by the need to balance immediate remediation with long-term stability and adherence to operational best practices. Correct approach analysis. The correct approach involves a methodical, layered investigation starting with the most probable and easily verifiable causes. This begins with examining the BIGIP LTM's health status and logs for any immediate anomalies related to the affected virtual server, pool members, or associated network components. This aligns with standard ITIL, Information Technology Infrastructure Library, incident management principles, emphasizing rapid diagnosis and resolution. Specifically, checking LTM logs for connection errors, resource exhaustion, CPU memory, or configuration mismatches provides direct evidence of potential LTM-related issues. Subsequently, verifying the health and responsiveness of the backend pool members from the LTM's perspective is crucial, as the LTM itself might be functioning correctly but unable to reach healthy application servers. This systematic progression ensures that the LTM's role is properly assessed before delving into more complex or external factors. This approach is professionally sound as it prioritizes efficiency, minimizes unnecessary changes, and focuses on data-driven troubleshooting, thereby reducing the risk of introducing new problems. Incorrect approach is analysis. One incorrect approach would be to immediately assume a network infrastructure issue outside the LTM and begin making broad changes to firewalls or routers without first validating the LTM's configuration and health. This violates the principle of isolating the problem domain and can lead to unintended consequences or mask the true root cause within the LTM. It also represents a failure to follow a structured troubleshooting methodology, potentially leading to extended downtime and increased operational costs. Another incorrect approach would be to immediately restart LTM services or reboot the BIGIP device without gathering sufficient diagnostic data. While a reboot can sometimes resolve transient issues, it is a disruptive action that can lead to data loss or further instability if not preceded by thorough log analysis and health checks. This approach bypasses critical diagnostic steps and is akin to treating symptoms without understanding the disease, which is professionally irresponsible and can violate change management policies if not properly documented and approved. A third incorrect approach would be to focus solely on the application code or backend server configurations without first confirming that the LTM is correctly directing traffic and that the pool members are reachable and responsive from the LTM's perspective. While application issues can cause performance degradation, it's essential to rule out LTM-related problems first, as the LTM is the gateway for traffic. Neglecting this initial LTM validation can lead to wasted effort on the wrong components and prolong the incident resolution time. Professional reasoning. Professionals should adopt a structured troubleshooting framework, such as a phased approach that begins with verifying the immediate environment, LTM health, logs, virtual server/pool status, then moves to the next layer of dependency, pool member health and connectivity, and finally expands to broader network or application components if the LTM and its direct dependencies are ruled out. This systematic process, often guided by vendor best practices and internal operational procedures, ensures that all potential causes are considered in a logical order, minimizing risk and maximizing the chances of a swift and accurate resolution. Documenting each step and the findings is also critical for knowledge sharing and future incident prevention. Question 20. The monitoring system demonstrates intermittent packet loss on a critical application's traffic flow during peak usage hours. What is the most appropriate initial course of action to diagnose and address this issue? Option A. Analyze historical BIGIP LTM performance statistics, connection table entries, and relevant event logs to identify patterns and potential root causes before making any configuration changes. Option B. Escalate the issue directly to the BIGIP vendor support team without performing any initial local troubleshooting. Option C. Immediately adjust the load balancing algorithm for the affected virtual server to a different method to see if it resolves the packet loss. Option D. Disable health monitors for the pool members associated with the critical application to prevent them from being marked as unavailable. Correct answer is A. Analyze historical BIGIP LTM performance statistics, connection table entries, and relevant event logs to identify patterns and potential root causes before making any configuration changes. Explanation. Scenario analysis. This scenario presents a common yet challenging situation in network operations. The monitoring system flagging intermittent packet loss on a critical application's traffic flow, especially during peak hours, immediately raises concerns about service availability and performance. The challenge lies in accurately diagnosing the root cause without disrupting ongoing services or making premature, potentially incorrect, changes. The intermittent nature of the issue further complicates diagnosis, as it may not be reproducible on demand. Professionals must balance the urgency of resolving the issue with the need for thorough investigation to avoid introducing new problems or misattributing the cause. Correct approach analysis. The correct approach involves a systematic, data-driven investigation that prioritizes understanding the scope and impact of the packet loss before implementing any changes. This aligns with best practices for IT service management and network operations, emphasizing a do-no-harm principle. By first analyzing historical performance data, traffic patterns, and BIG-IP LTM logs, such as connection table entries, statistics, and event logs, the administrator can identify potential correlations with specific events, client sources, or server responses. This methodical approach allows for the isolation of the problem to a specific component or configuration within the LTM or the broader network. This is professionally sound as it minimizes the risk of unintended consequences and ensures that any subsequent remediation steps are targeted and effective. It also supports compliance with service-level agreements, SLAs, by demonstrating a diligent effort to maintain service quality. Incorrect approach is analysis. Implementing immediate configuration changes without sufficient data is a significant regulatory and ethical failure. For instance, arbitrarily adjusting load balancing algorithms or connection timeouts could negatively impact application performance for all users, potentially violating SLAs and leading to customer dissatisfaction. This approach demonstrates a lack of due diligence and a failure to adhere to established ITIL or similar operational frameworks that mandate incident management processes involving diagnosis before resolution. Another incorrect approach, such as disabling health monitors for the affected pool members, is also professionally unacceptable. While it might temporarily mask the symptoms of packet loss by preventing the LTM from marking members as unavailable, it fails to address the underlying issue and could lead to traffic being sent to unhealthy servers, causing application errors and further service degradation. This is a direct violation of the principle of maintaining service integrity and could be seen as an attempt to circumvent monitoring rather than resolve the problem. Finally, immediately escalating the issue to a vendor without performing any initial troubleshooting steps is inefficient and unprofessional. While vendor support is crucial, a competent LTM specialist is expected to perform initial diagnostics to gather relevant information, which aids the vendor in faster resolution and demonstrates the administrator's capability. Failing to do so wastes valuable time and resources. Professional reasoning. Professionals should approach such situations by following a structured incident response framework. This typically involves 1. Identification, recognizing the issue through monitoring alerts. 2. Logging, documenting the incident with all relevant details. 3. Diagnosis, gathering data from logs, statistics, and network tools to understand the scope, impact, and potential causes. 4. Resolution, implementing targeted changes based on the diagnosis. 5. Verification, confirming the issue is resolved and monitoring for recurrence. 6. Closure, documenting the resolution and lessons learned. This systematic process ensures that decisions are informed, actions are justified, and the risk of negative impact is minimized, thereby upholding professional standards and regulatory compliance related to service availability and data integrity.